We're now going to look at a couple of application problems involving the mean of a random variable, okay? Or we can say the expected value of the random variable. And so this first one involves a raffle drawing. So there's 5,000 raffle tickets, and they are sold for $5 each. So it's like a fundraiser. And so the prizes here are the following. There's one grand prize of $5,000. There's $2,000 prizes, 10 $500 prizes, and 20 $100 prizes. And so those are the prizes. And now what we're curious is, what is the expected value of a ticket to someone who buys a ticket? What is, on average, what would they expect that ticket is worth? What is the expected value of the ticket? Well, the way that you find this is that you construct the probability distribution here for x, and x here is value of the ticket. We could say to one who buys it. Okay, the value of the ticket to the one who buys it is x. So now what we're going to do is we'll construct a probability distribution for x, and then we're going to just find the mean of that probability distribution, the expected value of the probability distribution. That's how we solve this. So now let's think about this. How much is that ticket worth to a person? Well, for most people, they're going to pay $5 for the ticket, and they're probably not going to win anything. Okay, there's only a handful of prizes. So for most people, it's worth a negative $5 because they're going to lose $5. Okay, but now there are these prizes here. Okay, so there are some prizes. And I'm going to start here at the $100 prize here. So there's there's 20 $100 prizes. But if you actually win a $100 prize, the ticket wasn't worth $100 to you. It was worth only $95. And the reason for that is you had to pay $5 for the ticket, right? You paid $5, you got 100. And so the difference between those is $95. So that ticket would be worth, that's the value of the ticket to you, okay? So again, if you won the $500 prize, it would be $495. So I have to subtract the $5 from each of these prizes. So if you won that $1,000 prize, it would be worth $995. And then if you won the grand prize, it would be worth $4,995. So these are the values that the ticket is worth to you. So now what about the probabilities? Okay? So this is what are the probabilities that you're actually going to get selected for the drawing for one of these? Okay, well there's 5,000 raffle tickets, right? So you have 5,000 names in a hat. What's the chance they're going to draw out your name for one of these prizes here? Okay, well there's only one grand prize. So the probability that your name will get drawn out for that grand prize is just 1 out of 5,000, because you only have one chance. But there's $2,000 prizes, so the probability that you'll get that is actually 2 out of 5,000. And then there's 10 $500 prizes, so this would be 10 out of 5,000. And then there's 20 $100 prizes. And so that would be 20 out of 5,000. That would be the chances of getting that $100 prize. But most likely you are going to lose $5. And so how many ways can you do that? Well, it looks like there's 33 prizes, 5,000 tickets, and so that leaves you 5,000 minus 33. There's 4,967 ways of losing out of 5,000. And so much, much more likely to lose $5 than to win one of these prizes. So now, what is the mean? So the mean is each value times its probability. And plugging all of this in, I get negative 5 times 4,967 divided by 500, or by 5,000, plus 95 times 20 divided by 5,000. And fortunately, you don't need any parentheses here or anything, because the order of operations is it'll do all the divisions before it does the adding. Okay, so 495 times 10 divided by 5,000 plus 995 times 2 divided by 5,000 plus 4,995. That'll be 1 times that, which will just be that. That times 1 divided by 5,000. So, assuming I put everything in there correctly, we get, and I think that is right, that's what I remember, we get that the ticket is worth a negative $2.20. So what is the expected value of the ticket? It's a negative $2.20. So it means when you take into account this great chance of losing $5 and these very small probabilities of winning one of these prizes, and you balance all that out, then you would expect, on average, to still lose $2.20. That would be the expected value of the ticket.